All right, I am going to go over all of the problems from the 5256 practice quiz. But before I do that, because I don't want to waste your time, here are the answers. Pause the video, check your answers. If you only need to see a few of the questions, then just fast forward to those questions and see those specific ones. I do want to point out that sometimes in worksheets and stuff we were doing, they were labeling this as -2 to 2. Increasing is technically defined as where the function is positive, and 0 is where it's negative. So some books you'll see them take the 0 out, some will include it. I always take it out because I feel like it's not 0 or it's not positive at 0. It's actually hits 0 there. So same thing for this number 1, part A. Some you'll see -3 to infinity. Same thing with number 4. -2 to 2. So anyway, you can pause here, see if you want to check over these answers, and then, like I said, just fast forward to the problems that you need to see. Otherwise, I'm just going to go through all the problems. So first of all, it's good to make some side notes here. So how do we know where something is increasing or decreasing? And something is increasing if I'll write it above here. It's increasing if f prime is positive, greater than 0, and it's decreasing if f prime is less than 0. Okay, so if we have f, we first of all got to find f prime. So f prime of x is 4x cubed plus 12x squared. All right, now if I want to see where it's positive or negative, the first thing I need to do is figure out where is it 0. So I'm going to factor 4x squared. I'm left with x plus 3. So this is 0 at 0 and -3. So what we're going to do here is set up our table now. So our table will include a blank space to start off with, and then our smallest number, -3. A number between -3 and the next number, which is 0, and then some number bigger than 0. Okay, so this is what our table will look like. I'm just going to clean up the table a little bit here. And we're going to plug in some values. Now, we already know that these both gave us 0, so we can fill zeros in there. I need a number less than -3, a number between -3 and 0, and a number bigger than 0. And again, I'm plugging this into my first derivative because that's what I want to know. I want to know where is the first derivative positive or negative. So first of all, hopefully you can see that this right here will always be positive. So we don't even really need to look at that when we're using these values because 4x squared is always positive regardless of what we plug in there. Other than 0, which we already know, 0 gave us 0. So -5 in the first one, -5 plus 3 is a negative. Next one, -1. -1 plus 3 is a positive. And then next 5 plus 3 is again a positive. So for our increasing values, where is it positive? Increasing. It's positive here and here. So like I said, I'm going to list this as -3 to 0 and 0 to infinity. And that's mainly because increasing is defined as where is it positive, and at 0 it is 0. So I take that out, but you will see some people just label that as -3 to infinity. Decreasing, where is it negative? Well, it's negative right here. And how do we write that in interval notation? Well, that is all the numbers less than -3, so we write it like that, -infinity to -3. Excuse me. All right. Next up, I want to know where is this function concave up, which means second derivative greater than 0, or where is it concave down, which means second derivative less than 0. So we first of all need to take our function, right here it is, our function's derivative, and we need to take the derivative of that to get us our second derivative. So the second derivative of x is, bring down to 3. 3 times 4 is 12. Subtract by 1, so 12x squared. Plus 2 times 12 is 24. Subtract by 1, we get 24x. All right, so there is your second derivative. I'm going to clean up that plus sign. It looks kind of funny. So there's your second derivative. All right, and again, just like in increasing and decreasing, to find out where this is positive and negative, I first need to know where is it 0. So I'm going to go ahead and factor again. In this case, I can take out a 12x, and I'm left with x plus 2. So this is 0 at 0 and negative 2. All right, so we're going to come to our table. I'm going to come to our table here, and I'm going to say x. And now I want to know second derivative. So second derivative, there's 2 dashes there. Second derivative. All right, so I need a number less than negative 2. So like negative 5. And then I'm going to put my negative 2 in there. That gave me 0. I need a number between negative 2 and 0, so negative 1. 0, I know gave me 0, and then I need a number bigger than 0, so I'm going to say 5. All right, now we got to plug these values into both. So negative 5 in here gives me a negative, and a negative 5 in here also gives me negative. So negative times negative is positive. Next up is negative 1, so negative 1 right here is negative. Negative 1 here is positive, so negative times positive is negative. And then 5, if I plug 5 in here, 5 gives me positive, times positive gives me positive. So to find out where this is concave up, it's wherever this is positive. So it's positive here and here. So write the intervals. This is negative infinity up to negative 2. And it's 0 to infinity. All right, that is everywhere that it is concave up. That's everywhere the second derivative is positive. And it's concave down wherever the second derivative is negative. So that would be negative 2 to 0. All right, so there's your number 1. Number 2, to find the relative extrema, this is, again, we're taking the derivative and set it equal to 0 to start off with. All right, so let's first of all, we're going to say f prime is our derivative, and this is going to be, now if you bring this 4 out front, you're going to have 4x cubed over 4. All right, so 4x cubed over 4 is just x cubed. All right, and you'll see this a lot. This is just kind of one of those like easy ways to make derivatives come out nice. Okay, so x to the 4th, if you bring that 4 out front, it's going to cancel with this 4 here. Just leave you with x cubed. So we got x cubed and we got a minus. 2 times 2 is 4x. And the derivative of 1 is 0. So again, we're going to set this equal to 0. But before that, I want to factor. That's what I was actually trying to do there. So take out an x. I'm left with x squared minus 4, which x squared minus 4 factors to x minus 2, x plus 2. So I know this is 0 at x equals 0, at x equals negative 2, and at x equals 2. Okay? Not in the order there. This would give you 2. This would give you negative 2. I just wrote my negative before my positive. I should have really wrote them all in order from least to greatest, but I didn't. All right, so we're going to, again, go to our table. So x, I'm going to leave a blank space. Smallest number is a negative 2. Blank space, next is 0. Blank space, next is 2. And then blank space. So this is what our table will start with. These are all zeros, okay? So I know that these 3 values are either a min or a max. Unless we end up with something like, if there's a positive, then that's not a min or a max. Okay, so just remember that it's a min if it goes from negative to positive, and it's a max if it goes from positive to negative. So you got to remember that. I know we did a bunch of things like that, but you got to remember that. So again, I'm looking at my first derivative. I need a number less than negative 2, so let's just say negative 5. You can use whatever you want. A number between negative 2 and 0, the only nice number is negative 1. But you're not limited to integers. You could use a fraction or whatever you wanted if that was, if you want to. I need a number between 0 and 2, so I'm going to say 1, and a number bigger than 2, so I'm going to say 5. So now I'm going to plug it into my first derivative, which is right here is the easy one to use. You can use either of these two forms if you want, but I wouldn't, just because this is already factored out for us and we can use our sign chart. So let's plug in -5. So -5 is going to give me a negative times a negative, which is positive. And then a positive times a negative is negative. So 3 negatives gives me negative. Plug in -1, we get a negative times a negative, which is a positive, times a positive is a positive. So that has 2 negatives, which is positive. So we plug in -1. I'm sorry, +1 now. We're at +1. +1 gives you positive, negative, positive. All right, positive, negative, positive is negative. And the last one, 5, gives you positive times positive times positive as a positive. So let's look at what we have here. A negative slope, we got a positive slope, we got a negative slope, and we got a positive slope. All right, so my answers here, let's start with the mins. A min, when you do this, it helps to see it a lot better that, these are the mins and the maxes. So we can see we have a min at x equals -2 because it goes from a negative slope to a positive slope. And then at +2 for the same reason, negative slope to positive slope. And then we have a max at x equals 0 because it goes from a positive slope to a negative slope. So that would be a max. All right, number 3. We, again, in order to find out the relative extrema, this is just like the last problem, we need to take the derivative. So the derivative is 3x squared minus 18x plus 15. Derivative of 18 is 0, so that one's gone. And again, we need to find out where this is 0, so let's go ahead and factor. So 3x squared minus 6x plus 5 equals 0. Keep factoring. You can get rid of the 3 because that's not going to do anything, or you can just bring it along. It doesn't really matter. Like I said, it's not going to provide a 0 for us, so you can get rid of it. And really what you're doing is dividing by 3, because 0 divided by 3 is just 0. So that's one option, or you can just leave it there. It doesn't really matter. So what makes this 0 is when x is 5 and when x is 1. There we go. So we're going to first of all, after we did our derivative, set it equal to 0. Now we have to do our table. So again, in our table, we need a number. Our smallest number is 1, so we need a blank space. And then 1, and then a blank space, and then 5, and then a blank space. So a number less than 1, really nice number to use there, is 0. First of all, let's fill in some zeros here. A number between 1 and 5, let's, 2, 3, 4, whatever you want to use. And a number bigger than 5, let's use 6. So if I come down here and I plug 0 in, we get negative times negative, which is positive. Then if I plug 2 in, I get a negative times a positive, which is negative. And then 6 gives you positive times positive, which is positive. So again, I got positive, negative, positive, which makes it a lot easier to see that my min is at x equals 5, because it goes from a negative slope to a positive slope. And my max is at 1 for the exact opposite reason. It goes from a positive slope to a negative slope. All right, for number 4, we are given a graph of the derivative. And again, it's important for you to recognize which function you are given. So just like in the last ones, if I'm trying to find out where it's increasing or decreasing, let me jump back to problem 1. That's where the derivative is 0. Well, first of all, we found out where the derivative was 0. Increasing is where the derivative is positive. Decreasing is where the derivative is negative. Okay, so we need to first of all go to our graph and find out where is it 0. So -2, 0, and 2. Okay, and now I need to see where is it positive for increasing. Okay, so the increasing is where is the graph positive, not where are the slopes positive, but where is the graph positive, because the graph f prime is the slopes. So everywhere that this graph is positive, that's going to be part of my increasing. So it's positive here and it's positive here. Okay, so that means I'm going to say -2 to 0 and 0 to 2. And I'm not including 0 because 0 is not positive, it's 0. Okay, so I'm going to take that out. To find out where it's decreasing, well, decreasing is everywhere that it's negative. Now, if you look at the graph, I don't know what's happening beyond -3. So I'm starting this at -3. And I don't know what's happening beyond 3 over here, so I'm ending it at 3. So these purple parts here are the parts where it is negative, and that's where it's decreasing. So I'm going to say -3 to -2 and 2 to 3. Okay, and we're also told in the graph here that this is the only part that we know. All right, number 5 is kind of along the same lines as what we just did, in that we're starting off with the same point. So if we're finding the relative extrema, we're basically just looking for the max and the min. We need to first of all see where is this graph 0. So we know at these points right here, it is 0, okay? Now, to label the max and the min, what we need to do is we need to identify where is this graph changing from, for a max, is going from positive to negative, and a min is negative to positive, okay? So again, if we're given the derivative, we're looking at the values, not the slopes. So for the min, if we look, these are negative right here up to positive. So that means this is a min. Also at 3, the values go from negative to positive. Okay, negative values to positive values. So this is a min as well. So let's label that min at x equals -3 and x equals 3. And then because this value here at -1 goes from positive values to negative values, positive to negative means max. So we'll have a max at x equals -1. All right, now the last two, or I should say number 6, I'm actually giving you the derivative. Okay, so I'm giving you f prime. So to find the relative max and min, you start with f prime and find out where is it 0. So let's set this equal to 0. Oops. And we're gonna start this off by factoring. So I'm gonna factor out a 3. And then we can see I'm left with x squared minus 4, which is x plus 2, x minus 2. All right. We're basically doing the same thing for all of these problems. Take the derivative, set it equal to 0. This one we're already given the derivative, so it's easier. You just set it equal to 0. So -2 and 2 are your zeros. So that means that in our table, we need a value less than -2. I need a value between -2 and 0. Or I'm sorry, a value between -2 and 2. I'm going to use 0. And then a value bigger than 2. So a value less than -2 is like -5. Between -2 and 2 would be 0. And then bigger than 2, we'll just use 5. All right, so again, let's see what we get here. Now I know -2 and 2 gave me 0. So when I use -5, I get negative times negative, which is positive. 0 is going to give me positive times negative, which is negative. And 5 will give me positive times positive, which is positive. So max and mins, again, we look for where the slope is positive, negative, positive. So for a max, we'd be right here. the min would be right here. So that means the min, again, goes from a negative slope to a positive slope. So that would be x equals 2. And a max would be at negative 2 because that goes from a positive slope to a negative slope. All right, last one here. We're trying to find the intervals of concavity. We want to know where is this concave up and concave down. Concavity is dealing with the second derivative. So we got to go straight to our second derivative before we do anything. So first derivative, we got to go through the first derivative. Okay, so 12x squared minus 36x minus 4. And then our second derivative is 12x squared plus 24x minus 36. All right, now we have to figure out concavity, where we're trying to find out if it's concave up or concave down. That's where the second derivative is positive and negative. So we need to figure out where the second derivative is 0. So the second derivative equals 0. Let's first of all factor this. We could take a 12 out, and then we're left with x squared plus 2x minus 3, which this factors to x plus 3 and x minus 1. All right, and again, we're trying to find out where is this 0. So we now know that it's 0 at x equals negative 3 and at x equals 1. So we want to go ahead and make up our table. So our table, we need a value less than negative 3. I'm going to put negative 3 in. A value between negative 3 and 1, and then a value bigger than 1. These both gave me a 0. So a number less than negative 3, let's say negative 5. A number between negative 3 and 1, let's use 0. And then a number bigger than 1, I'm just going to use 5. So back here, if I plug in negative 5, I have negative times negative is positive. And if I plug in 0, I get positive times negative, which is negative. And lastly, if I plug in 5, I get positive times positive, which is positive. So concave up is wherever the second derivative is, that's an arrow pointing up, is wherever your second derivative is positive. So that would be negative infinity up to negative 3. And again, you want to make sure you're using these numbers here and not the ones you chose to plug in. You want the ones that are 0. Our last interval where it's positive would go from 1 to infinity. Okay, and it's concave down in the middle here where it's negative, so that would be negative 3 to 1. Okay, so again, quiz Wednesday. So if you have any questions on this, let me know. Otherwise, you have your quiz Wednesday. So if you do have any questions, just send me an email or a private comment.